Hello, everyone, and welcome back. My name is Mr. Koval, and in this video, I'm going to go over molarity and equation stoichiometry. So let's get into this. So, with equation stoichiometry, it's like I said in the last video, you're using a balanced equation in order to go from one substance to a different substance in the equation. So basically, you're given a certain amount of one substance and you're converting that to an amount of a given substance. So, for example, if you're given an amount of one reactant, and you might be asked, well, how much of another reactant or the other reactant do I need to react completely with the amount of this other reactant that I have? Or you could be given an amount of reactant, and then you'd be asked, well, how much product can I form from this reactant? Or you could be given an amount of product that was formed, and you could be asked, well, how much reactant did I start with to get this amount of product? So those are a few examples of how stoichiometry works. And so when you throw molarity in there, molarity is basically another conversion factor that you can use to help you convert from one substance to the other. So remember, molarity is, and I'll just write it up here briefly. So remember, molarity is equal to the moles of solute over liters of solution. So since you have a ratio here, you can use this as a conversion factor to convert between liters of a solution and moles of the solute in the solution. So this is a way to get to moles. So if you remember in my previous videos where I was talking about mass to mass conversions, you remember this roadmap here. Well, you started out with a certain unit of mass for substance one, and then you converted that unit to grams, right? Because using some sort of analysis, unit analysis conversion factors like 1 kilogram is equal to 1,000 grams. So you can go from whatever unit you have, say kilograms to grams, right? And then once you add grams, then you could use the molar mass to convert to moles, use the mole ratio in the equation to convert that to moles of your other substance, substance 2 in this case, and then you could use the molar mass of that new substance, substance 2, to convert to grams of that substance, and then use unit analysis conversion factors to convert from grams to whatever unit they wanted you to get, right? So it could be kilograms, milligrams, any mass unit that you want that they are asking for. It could be pounds or ounces or whatever. Now, in this video, we're going to use molarity to help us get to moles. So the roadmap is slightly different, but it's pretty much the same idea, the same strategy. Again, there's 3 steps, right? Step 1, whatever unit you're given, the first goal, the first ultimate goal that you want to get to is moles of that substance. So if you're given a unit of a substance number 1, you want to get that to moles. So you're going to find conversion factors to help you get to moles of that substance. And then second step, So the second step, so you could view this as the first step, going from units of whatever substance you have to moles of that substance. And then the second step is to use the mole ratio to convert from moles of that substance number 1 to moles of whatever the second substance is. And then the third and final step is once you get moles of that second substance, you're just going to use conversion factors to convert to whatever desired unit they want you to convert to, right? So those are the 3 basic steps. Take the unit of substance 1, convert that to moles in some way, right? So using the conversion factors that are available to you, get it to moles. Step 2, use the mole ratio that you have in your balanced equation to convert moles of substance 1 to moles of substance 2. And then third, once you got moles of substance 2, use whatever conversion factors that are available to convert from moles to that desired unit. Okay. Now, that video that I went over that was dealing with a mass to mass conversion. Here we're going to use molarity, where it's going to be more like a volume to volume conversion. And so we're going to use molarity to convert from a given volume to moles. So again, the goal is to get to moles. Once you got to moles, you're going to convert using your mole ratio that we get from our balanced equation. Okay, so just like to walk through this step by step. So in this video, what we're going to be given is some unit of a substance in a volume unit, right? So it could be milliliters, it could be liters, it could be microliters, whatever the case may be. It's going to be a volume unit. So you're given this volume unit, and your first step is to get to liters of substance one. Once you get to liters of substance one, you can now use the molarity of substance one, which again is the relationship between liters of the substance and the moles of the solute. So I can now use the molarity of substance one to convert from liters to moles. Now that I have moles, I can now use something like a balanced equation, use the coefficients in the balanced equation as a mole ratio to convert from moles of substance 1 to moles of substance 2. Now that I have moles of substance 2, it's just a matter of converting to whatever unit they want. In this case, we're assuming they want to get to a desired volume unit. So now what I would do is use the molarity of substance 2 to then convert from moles to liters of substance 2, and then use some conversion factors to try to get to from liters to whatever unit they want, maybe milliliters, maybe something else, right? So this is our roadmap. These are our steps, okay? So what I'm going to do now is I'm going to go over an example to kind of show you how it's done. So in this example, I'm given some silver nitrate reacting with sodium phosphate to produce some silver phosphate solid and some sodium nitrate. And so what the problem is asking me is if I'm given 25 milliliters of 0.500 molar solution of sodium phosphate, how much of this solution of silver nitrate would I need to precipitate out all of the phosphate that I have, right? So I need to figure out how much of this do I need to react completely with this. That's the question here. So they're giving me a volume of this substance here, and I need to find what volume of this substance do I need to react completely with all of this. So what you're going to do is you're going to convert. You got to start with the given. So this is our given volume of the substance. Now, we're not going to start with molarity. Molarity is a conversion factor. So you don't really start with a conversion factor. You start with something else that they give you, some piece of information that isn't a conversion factor. It's not a relationship. It's just one unit. And so here they're giving us 25 milliliters of this solution. So that's what we're going to start with. So we start with 25 milliliters of the solution, 25.00 milliliters of, and it's going to be Na3PO4. And I'm going to put that over 1. And so here I am. I have a given unit of a substance. So my first step is to get to liters. I want to get that to liters. I have milliliters. So I'm going to use the 1 milliliter is equal to 1,000th of a liter, or 10 to the negative 3. Or you could use that 1 liter is equal to 1,000 milliliters. Either way is fine. So here, since I have milliliters on the top, I'm going to have milliliters on the bottom. So 1 milliliter of Na3PO4 is going to be equal to 10 to the negative 3, or 1/1000th of a liter of Na3PO4. PO4. So milliliters cancel out. So now I have liters. So I've done this step here. I have liters of substance 1. So now I can use the molarity to convert from liters to moles. So what's the molarity of Na3PO4, sodium phosphate? 0.500 moles per liter. So I'm going to use that as a conversion factor. So since I have liters on the top, I'm going to have liters on the bottom. So that's going to be 1 liter of the Na3PO4 solution. And then on top is going to be the moles. Well, how many moles? 0.500 moles, because that's the definition of molarity. So 0.5 moles. And again, that's going to be moles of Na3PO4. So liters of Na3PO4 will cancel out, liters of Na3PO4. And now I have moles of the sodium phosphate on top. So now I've done this step. So now I'm here. So I've used molarity as a conversion factor. Now I'm at moles of substance 1. Now that I'm at moles, I've kind of done my first large step. So now I can go to the second step, which is to use the mole ratio to convert from moles of one thing to moles of another thing. So here I'm going to use the mole ratio between silver nitrate and sodium phosphate. It's a 3-to-1 ratio. So I'm going to continue down here because I don't have room. So I know that, so here I have moles of sodium phosphate. So I'm going to put moles of sodium phosphate on the bottom. So that's going to be 1 to 3. So 1 on the bottom, 1 mole of the sodium phosphate, and then 3 moles of the silver nitrate. And so the moles of the sodium phosphate cancel out. And now I have moles of my substance number 2, which is silver nitrate. So now I've gone from moles of substance 1 to moles of substance 2. Okay, so now I'm ready to go down to whatever desired unit I have. So now I'm into the large step 3. So I am going to convert moles of substance 2 to whatever the desired unit is. Let's say the desired unit is milliliters, right? So here they're asking for milliliters, so I need to get to milliliters. The first thing I need to do is convert moles to liters using the molarity of the second substance. So here they're giving me a molarity of 1.00 molar, which is moles per liter. So now I can use that to convert the moles of silver nitrate to liters of silver nitrate solution. So it's 1.00 moles per liter. So since I have moles on the top here, I'm going to put moles on the bottom. So that's 1.00 moles. Moles of what? Silver nitrate. AgNO3. And so now I'm going to have liters on the top. So 1 liter of the silver nitrate on top. So moles of the silver nitrate cancel out. Now I have liters of silver nitrate on the top. Now I'm here, liters of substance 2. And now I just need to convert that to milliliters, which is the unit that they want me to get the substance in. So that's what I am going to do. So now I'm going to use the conversion factor between liters and milliliters again, same as before. So here I had 10 to the negative 3 liters is equal to 1 milliliter. This time I have liters on top, so liters is going to go on the bottom. So here 10 to the minus 3 liters of silver nitrate AgNO3 is on the bottom, and 1 milliliter of this silver nitrate is on top. So liters cancels out. Now I have milliliters. So at this point, I'm done. Once you get the unit you want with the substance, you're done. So now all you need to do is multiply by everything on the top and then divide by everything on the bottom, and you'll get your answer. And that answer is 37.5 milliliters of silver nitrate solution. So that's the answer. So in order to react this completely with 25 milliliters of 0.5 molar solution, in order to react completely with this amount of this molar solution here, I need 37.5 milliliters of the other reactant, silver nitrate. So the answer here is 37.5 milliliters. And so that's how you can use molarity to help you solve equation stoichiometry problems. So I hope this was helpful. If this was helpful in any way, if you enjoyed this video, then please like the video, share the video, hit that like button. Also, make sure you subscribe to my channel. Yes, definitely subscribe to my channel. Hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic or if you have a problem or a particular question you want answered, put that down below. I would love to do that for you. Thanks for joining me and have a great day.